Hello friends, today we are going to cover chapter 2 serialization with memory buffer. So here we are talking about this flow. We have got a Java object and we serialize it using the serialization techniques, which we'll cover later, that how to convert it into stream of bytes, and then we store it into memory here, this flow, and then we again deserialize it into stream of bytes, and then finally reconstruct this Java object. One thing to notice here is that when we did in the previous video, we serialized the stream of bytes into a file, and then the JVM could be shut down or restarted later on, and then we could have just reconstructed or deserialized from that file after the JVM restart. But in this approach, when we are storing the stream of bytes into memory, because we know that memory is volatile, whenever the JVM would shut down, everything in the memory would be erased. So in that case, this flow is not useful, and it should be used only the single run of JVM. Also, for the use case, we can do the similar thing. Instead of doing the serialization into memory and deserialize it to reconstruct the object in the same JVM, then same JVM means that we are not going to restart it. In that case, also, we could just use a collection framework. For example, we can store this object into list, set, or even a map, and then pass it across the multiple classes in the JVM, in the same JVM. So the use case for this is also limited, but nevertheless, we need to understand that there are APIs available to avail this type of flow, where we could use the memory buffer for our serialization and deserialization process. So as discussed, we are going to convert this Java object and serialize it to a byte array. Okay, the stream of bytes means byte array, and we'll store it into memory. And then during the deserialization, we'll take it from the memory and then deserialize from the byte array, which we have stored, and reconstruct the Java object. And the classes that we are going to use for manipulating this byte arrays is ByteArrayOutputStream. So this ByteArrayOutputStream class is used to serialize to ByteArray. This class implements an output stream in which the data is written into a byte array. The buffer automatically grows as data is written to it. The data can be retrieved using these toByteArray and toString methods. So if you look at the JDK API for ByteArrayOutputStream, it's same as we mentioned, and we don't need to actually, this is not something we try with resources because it doesn't generate any IO exception, and the buffer automatically grows as data is written to it. And for the field summary, we can see that this is the byte array where the data is stored, and this is the count or the number of valid bytes in the buffer. Similarly, to deserialize from byte array, we will be using ByteArrayInputStream class. Now, this class contains an internal buffer that contains bytes that may be read from the stream. An internal counter keeps track of the next byte to be supplied by the read method. So if we go back to this in the Java APIs, it's same as what I just mentioned. It is again closing a byte stream. ByteArrayInputStream has no effect. The method in this class can be called after the stream has been closed without generating an IO exception. And if you look at the field summary, it's very much similar to the ByteArrayOutputStream, where we have a byte array where the array of bytes are that was provided by the creator of the stream, count for the number of valid bytes and all. So this is all about this. So mark and position. So we'll just care about this buffer byte array, which we are going to use. And as discussed, the drawback using memory buffer is that once the JVM shut down, everything in the memory would be erased, and the serialized data in the memory cannot be used after application restart. Yeah, so guys, in the next video, we will dive into IntelliJ, and we'll write the code and the unit test cases to further enhance our knowledge and understanding about serialization with memory buffer. So see you all in the next video.